I'm sorry.
Morning, everyone. And I guess to actually link through to one of the last comments, you will notice the word open, and this is absolutely deliberate in this project, and we'll go into that. So we started this project around the Open Pharmacological Concepts Triple Store. We started in March last year. We're a 3-year program doing agile infrastructure development across 27 partners at speed, so it brings its own particular interests. I'm the FPA coordinator on behalf of Pfizer, and Gerhard's leads the managing entity from the University of Vienna. So we're just going to go into a bit of background for what the FPA thinking was behind why we wanted to launch this call. Basically, all the companies access, process, store, and reprocess data in different ways, and most of us are using. This is pointed very much in the early drug discovery phase. Most of us are using the same public data sources like GenBank, PubChem, all the literature. Those are built into databases. We might download those, and companies have done more or less the same thing with more or less the same data, installing that behind firewalls, running their own data mining, data analysis, knowledge management, data integration behind that. So if you look across the industry, then of course we were doing this several times, and this list isn't meant to be exhaustive, but of course every company was doing this in some shape or form. And we were having discussions around, at least in the pre-competitive field, would it not be better to do this once openly in the public domain with all the basic data everyone uses? From the FPA perspective, it would allow us to be much more efficient in terms of resource, but also there's a lot of bound up tacit knowledge in how this data is plumbed together and integrated that really would be a big advantage to the public domain. Compounds that are published in the literature as being selective that the industry knows very well aren't selective, or that are agonists that the industry knows to be a partial agonist, and there's no place to put a lot of this data openly in the public domain till now, and that's one of the things that Open PHACTS is trying to do. So this is, I guess, our mission statement. We're a user-friendly, full-featured interface that allows scientists to explore and integrate integrated biological and chemical data, pharmacology data, isolated enzyme screens, primary, secondary screens, a lot of the data that is sitting about out there in PubChem and the like. That's what the aim of this project is for. So the open pharmacological space will allow us to build services that integrate data on target expression, biological pathways, try to identify points for potential decent therapeutic intervention. You investigate a lot of the in vitro pharmacology and mode of action data on targets, as well as trying to find out what's gone on already around a particular compound or a particular target. That's something that's actually quite hard to do unless you're an expert in the various systems and databases where all this data currently sits. Having something that might work like a Google kind of interface for people who wear a lab coat for a living would be a real advantage. Currently, this is kind of stuck in the domain of computational specialists, and not everyone has access to those. And particularly as you move on, I guess, to some of the more advanced potential uses, comparing interaction profiles, starting to think about what off-target pharmacology looks like, what polypharmacology looks like, and analysing some of the motifs, getting more into that kind of chemistry space and serious analytics. So we're not necessarily going to be building new algorithms to do that, but what we are going to do is organise all the data to make that available in an open infrastructure that will allow people to build services on top of it. We've kind of split into I guess, the three major work streams, building, driving, and sustaining. Really, you will see, without going into too much of the detail, there is a big semantic web, semantic data technologies underneath this, which is actually a whole field of research in its own right, trying to make semantics work in the drug discovery space with some impact for the first time. And combined with that comes a kind of services for what can you actually do with this data. So the first part of the research which we've been engaged in, certainly in the last 15 months, has been the semantics and the build of the system, and we're starting to move more into how do we do the analytics piece. Uniquely, I think we're very consciously aware of the sustain for this project. As I said before, we are a 3-year program, and building any sort of software computational infrastructure, it's an expensive business to build it, but it's also an expensive business to keep that up to date, continually add new data and develop new functionalities. So we have 2 work packages aiming at building a community around the infrastructure that we build, and trying to share data from this and other programs as a seed for what could build into a much larger open space. So I guess this slide captures how we're trying to describe that in terms of the 3 pillars of the open FACTS, the open pharmacological space. Is the pre-competitive infrastructure that builds the integrated data, puts it in one place and exposes a lot of that industry tacit knowledge about compound pharmacology. We started to do some pharmacology use cases that answer what we're terming business questions, and there's nothing spectacular about these. It's fairly simple things like how many compounds hit this particular target with a potency of less than 50 nanomolar, that kind of standard bread and butter things. And then underneath that is part of the semantic research we're doing is also around a new data publishing methodology. People may have seen nano publications appearing in the literature in different shapes and forms. There's a lot of work going around to how we can define this, how we can take data not just as a data endpoint, but bring in the provenance of that data. Where was it generated? What was the context? So it makes it much more useful for reuse of that data in mining strategies down the line. So that's a lot of the background. Where have we got to? So in the first year of the project, we hit all our milestones, and we have an internal release of we can call it an alpha release of the software system within the consortium, which we've integrated lots of data on enzyme, Chemical Drug Bank, concept wiki IDs, and ChemSpider. That may or may not mean anything to you. If you want to know what some of those things are, you can talk to me later. So we're currently in the process of testing that and validating within the consortium. And we're also starting to think about pharmacology data by target, what can we find out about this particular compound, and just the standard, fairly simplistic queries that will be done through this basic interface. As Gerhard said before, we do have a live demonstrator of this, but just to save any potential technical glitches, I've got the screenshot demonstrator so you can actually see what some of these things look like. So I guess fairly standard to some other things you use. You can type the name of a compound in a box and you'll get a page back saying what we know about this compound, what data have we been able to pull back from the integrated data sources. So in this example, it's Gleevec. It gives you all sorts of things that you may or may not want to know, but is at least in this instance, shows we've taken from 3 or 4 different sources to integrate that data into a page that means something to you. We can do the same for targets. This is epidermal growth factor receptor, and we can go into a deeper, meaningful debate about how you define what molecular targets are, but we are very liberal in how we do that because we have to respond to the biology, not to the semantics and the ontologies. And again, this takes several different data sources, puts that together on a page that you can look up. But of course we can go beyond the simple look up things and start to ask more complex questions. This one is trying to find all the compounds that hit this particular target. You can get data back that you can cut and paste out into Excel if you want to, take the chemical structure, give you details on the potency and those sort of things. This serves as I guess, substrate for some of the downstream analytics that the data miners are able to do if they so choose.